In this video we're looking at a different idea. We're looking at the idea that acids can be classified as being either strong or weak. So we're going to understand what that means in this video. So I'll give you some time to have a look at this graphic. Here we've got the acid molecule. We've got one red part, one white part. And the white part is a proton, which is what we are commonly calling at the moment a hydrogen ion. And then we've got a negative ion. So if it was hydrochloric acid, this red particle here would represent chloride ion. So clearly hydrogen chloride is being split up into a hydrogen ion and a chloride ion. So if you pause the video, have a look at the diagrams. What do you understand by strong and weak acid? So if we look at the diagram, you'll see the left one is very similar to the right one, certainly in terms of volume, per unit volume. Wherever there is a particle on the left, there's a corresponding particle on the right. With an exception, we notice that the strong acid has more of the hydrogen ions free in solution. So what's happening is this acid molecule is splitting into its positive hydrogen ions and also its corresponding negative ions, and the strong acid does that more readily than the weak acid. So the weak acid, you can see some hydrogen ions, but there are fewer of them. So here we are, definition of a strong acid. We're saying that this acid molecule completely dissociates or splits into ions when dissolved in water. And here we've got an equation representing that. You've got hydrogen chloride as a gas dissolving into water, AQ representing water. And we can see that that molecule is splitting into hydrogen ions and also chloride ions. Now with a strong acid, this dissociation is very, very strong. The molecule is only too happy to get rid of these hydrogen ions. We could say 100% of these hydrogen chloride molecules split up, giving these hydrogen ions. So very efficiently splitting up, providing hydrogen ions in solution. We know those hydrogen ions are going to lower the pH. Let's have a look at a weak acid by comparison. So here we're identifying that it only partially dissociates. Now the example of a weak acid here is ethanoic acid. Strong acids tend to be our laboratory acids, hydrochloric, nitric and sulfuric. But here we've got ethanoic acid. So there's the ethanoic acid molecule. This happens to exist as a liquid. It's dissolved in water and it's splitting. So here we can see the hydrogen ions that are splitting, but we also notice that we've got this symbol here. So that's reversible. It's showing that the reaction doesn't just move to the left, doesn't just move to the right hand side, it also moves back towards the left. In other words, what we're saying is very few of these ethanoic acid molecules actually split to produce hydrogen ions. So a weak acid isn't so keen to lose its hydrogen ions. It doesn't split, it doesn't dissociate. In the EDEXCEL GCSE textbook, they provide us with this table, and importantly they tell us that the acids are all in equal concentration. But when we compare them, we can see that the pH is different. We can identify those acids with a low pH, and these are what we refer to as our strong acids. So these three are strong acids, nitric, sulfuric and hydrochloric, whereas carbonic acid, ethanoic acid and boric acid are weak acids in comparison. Okay, so a little question just to test our understanding. About 1 in 60,000 butanoic acid molecules release hydrogen ions when they dissolve, while nearly all hydrogen iodide molecules do so. Explain which acid is a weak acid, and explain which acid will have the higher pH, if both are the same concentration. So have a go at answering those questions, and then you can have a look at the answers in a moment. So here are your answers. Obviously we're told that butanoic acid is clearly a weak acid because only 1 in 60,000 dissociate, whilst nearly all the hydrogen iodide molecules dissociate. So that's pretty straightforward. Given that both these acids are at the same concentration, because we know that concentration can affect pH, so if concentration between the acids is the same, then the reason for a pH difference will be down to how strong or weak the acid is. Now, because butanoic acid is a weak acid, it's going to have the higher pH. Well done, you now know the difference between strong and weak acids.